Archaeology studies how people lived in the past. It tells us how they lived in and with the landscape that surrounded them. In the Carib project, we look at how people lived in the Lesser Antilles. The last 1,000 years was a time of many changes. Humans lived in and moved between the islands. Each time new people arrived, they brought their own ideas and beliefs. When Europeans and Africans came, new materials were also introduced.
Archaeology reconstructs history from the little objects that remained buried in the ground. This film is about how we look at the Antilles from 1,000 years ago. We study the objects, the materials that the people then left behind, ceramics. But what exactly is a ceramic?
Everyone knows mud. If you step in a puddle, mud sticks to your shoes and clothes. This is because minerals in the mud are small and look like tiny plates. They're called clays. Water attaches itself to clay plates and makes mud soft and sticky. Not all minerals in mud are clays. Mud is a mixture of many different minerals. The more clay minerals present, the stickier the mud becomes. When you leave mud in the sun, it dries. The heat evaporates the water between the tiny plates of clay. The mud becomes dry and hard, but you can still break it apart with your hands. You can heat mud in an open fire or kiln. At higher temperatures, clay will melt and connect to each other. A network of fused molten clay will make the mud very hard. It is now a very hard material, tough to break by hand. Now you have a ceramic.
So you can heat clay at high temperatures to make a ceramic. But why is a ceramic useful?
Wet mud with many clays is soft and sticky. You can shape it into many forms. In a kiln, you can fire the shaped mud. In this way, you can make useful ceramics, like plates or cups. The oldest ceramic objects were small statues used in rituals. They're nearly 30,000 years old. They were found in the Czech Republic. The oldest pottery is baked clay in the form of pots, cups and plates. This is found all over the world from about 20,000 years ago. The first ceramic pots were made using sausages of clay called coils. These were bent and stacked by hand to build a pot. Later on, lumps of clay were shaped on a potter's wheel. As soon as it is shaped, clay can be dried and fired. Ceramic is still made today. We still make the same objects, from bricks and tiles to cups and plates.
Clay can be made into many useful things. But why do we study ceramics?
Clay is found everywhere, so ceramic can be made all over the world. For thousands of years, humans have made objects from fired clay. Many of these were for daily use, such as cooking. Others were for rituals or special occasions, such as burials. All these objects could be made and used locally. The shape given to a ceramic is often typical of the place that it was made. It is a typical style for certain people in a specific place, a bit like fashion today. Since they're easy to carry, ceramics can be moved. They can be exchanged for other goods or taken on travels. We can analyse from which clay an object was made. Then we also know where it was made. If a ceramic is not found in the place that it was made, it was moved. This also allows us to see from where and possibly with whom an object travelled.
We want to know where a ceramic is made. We investigate which clay was used to make it. We look at the mineral properties of the ceramic and clay and compare them. For this, we use a microscope.
A slice of ceramic is cut and polished until it is very thin. When this is about 30 times smaller than a millimetre, light can pass through it. We call this slice a a thin section. We look at thin sections under a microscope. It shows the inside structure of the ceramic magnified in great detail. Materials, such as ceramic, are made up of crystals and minerals. These interact with the rays of light coming from the lamp of the microscope. Different crystals in the ceramic will appear with different colours and textures. We can now see what minerals are in the thin section. This tells us what materials were used to make the ceramic.
Another way to compare clay and ceramic is to look at their chemical composition. We look at which atoms are there and how many.
There are billions and billions of atoms in any material. We cannot just count them individually. We use a trick. Each type of atom reveals itself by sending us its typical energy. In the laboratory, we split the material we investigate into its atoms. We grind a sample to powder and dissolve it in acid. We bring this solution into a plasma, a gas at 8,000 degrees centigrade. This adds so much energy that all the chemical bonds are broken. All atoms get a higher energy content. They are excited. An excited atom has captured an extra amount of energy. But this is not a stable situation. The atom wants to lose the energy. It does this by emitting light or radiation. The energy emitted is different for each element. Energy can be counted much more easily than individual atoms. If more of a specific energy is measured, this means more of a particular element is present. Another way to excite atoms is to irradiate a ceramic with X-rays. With this technique, the ceramic does not have to be destroyed. This method tells us which type of atoms are present in the ceramic. However, it's less accurate in showing how much is there. Laboratory work tells us the mineralogical and chemical properties of ceramic and clay. If all the properties match, then the clay is a likely raw material for making the ceramic. If some properties don't match, we haven't found the right clay. Let's look at an example. Most ceramics from Argyll on St. Vincent are about 300 years old. They have very similar microscopic and chemical properties. These match well with the local clays from the island. These ceramics are probably locally made in St. Vincent. Ceramics from Grenada also have very similar microscopic and chemical properties. They are different, however, from the ceramics of St. Vincent. Here, we are looking at a local production of ceramics in Grenada. This analysis allows us to distinguish Grenada ceramics from St. Vincent ceramics. However, some ceramics from Argyll do not have the properties of the local groups. They do match with the features of ceramic made in Grenada. This is proof of a connection between St. Vincent and Grenada. It is these findings that archaeologists use to unravel history. How and why has this pot moved from one island to another? Or maybe the clay to make the pot was transported. In the Carib project, we look at many different islands in the Lesser Antilles. We reconstruct which ceramic was made where and when. We compare ceramics and clays. In this way, we can see how ceramic travelled. We can also see how people interacted.
Using scientific analysis, we can reconstruct how and where ancient objects were made. The life cycle of these objects, such as ceramics, can tell us a lot about how ancient people lived. In this way, science and archaeology work together to teach us more about our past.